Okay, good morning, welcome to everyone, both in person and online. We are at the 15th seminar organized by Annals of Geophysics journal and for the 25th anniversary of INGV. Today we are pleased to have as our guest Professor Irene Manzella. And I would like to thank Irene for her participation. And as usual, a brief biography will be introduced by Daniele Morgavi from the University of Naples Federico II. And after the discussion also will be moderated by Daniele. Thank you all and enjoy the talk.
Okay, hi everyone. I would like to state first for the people who are watching online that if they want to ask questions after the presentation, they should click the link, which is ask your question, and fill up the form, and then I will read the question for you. I would like to thank the editor-in-chief of Annals of Geophysics for organizing this seminar. And before we start, let me introduce you to the presenter, Professor Irene Manzella. She's going to talk about multi-hazard in volcanic environment and the importance of inter- and transdisciplinary for increasing resilience. Professor Manzella is an associate professor at the Faculty of Geo-Information Science and Earth Observation of the University of Twente in the Netherlands and head of the Center for Disaster Resilience. A research field extends across the study of hazards and risk assessment of multiple and complex phenomena with a multidisciplinary approach with expertise in environmental science, engineering, and disaster resilience. Her education starts from the Politecnico di Milano in environmental and geotechnical engineer. Then she gained a Master of Advanced Study, Settlement Upgrading for Cooperation and Development for the Politecnico di Milano. She gained a PhD at the Rock Mechanical Laboratory, École Polytechnique Fédérale de Lausanne, in dry rock avalanche propagation, and a postgraduate certificate in academic practice, University of Plymouth. A working career, she carried out a postdoc at the Civil Engineer Department at the Massachusetts Institute of Technology, and a postdoc and a senior research and teaching assistant role at the University of Geneva. She has worked as assistant professor first and then as associate professor in engineer geology and geohazard at the University of Plymouth in UK. Okay, thank you very much and enjoy the seminar.
Thank you, Daniele, thank you, Paola, for this introduction, and thank you, everybody here and online for being here. The camera is there, right? And yes, and I'm really honored to be here to celebrate this 25th anniversary of the INGV, and I think that also because INGV also embrace this multidisciplinarity and transdisciplinarity in their work. So I think that it's the good place to talk about this. But so this presentation will be a bit an overview of some of the projects that I've been working in recent year, and of course there is the contribution of a lot of co-authors and that I've listed there, and that I will thank also at the end. So first of all, this the story of this presentation, it starts with my personal story. So when I was a kid in the first day of the secondary school, our teacher asked us what we wanted to be as a grown-up. And I really loved math and physics, but I also really loved nature and the environment. And so I said, I really had already clear idea what I wanted to be, and I said I wanted to be an engineer that works for the planet. And all my story and all what I've done in my career, it has been towards reaching this kind of dream that I had when I was a kid. But then as I grow up, I realized that to work for improving our environment or to kind of care for our planet, we need to increase, so we need to collaborate and have a transdisciplinary and interdisciplinary approach. And so I will walk you through the project that I work on with also the thinking that has brought these different things into my career and my work. So this is a brief outline of what I will be talking. So I will look in more in the volcanic multi-hazard context, and then I will go in deep into the Stromboli case study. That is also the topic of the article for the Annals of Geophysics. And then we will look into impact chains, and also at the end we will see how we can push the frontiers of interdisciplinarity or multidisciplinarities with technology and art. So we all know that we are facing global challenges in disaster risk, that there is a rise in the impacts, and there is also an uneven distribution of this impact because they often affect disproportionately the low and middle income countries, and we also learn, and in the hard way, I would say, with the COVID-19 pandemic, that we are really interconnected, and we have to deal with the global risk in collaboration with the internationally and interdisciplinary. And not only the pandemic, it has taught us the kind of power of cross-border geohazards and the impact that they can have. So we have seen with the Eyjafjallajökull eruption, the Indian Ocean tsunami, but also in a more maybe unseen way, we can see also that the impact of, for example, of tsunami, of seafloor cable damage could have a global impact, even if it's less, say, a spectacular event or less seen event, I would say. So why volcanoes for multi-hazard? I would say volcanic environments, they are inherently multi-hazard. They present a complex and multi-hazard scenario where the primary volcanic activity can trigger cascading hazards, or multiple hazards can occur also simultaneously. And then we have complex interrelationship also in between these hazards, so they can be triggering, amplifying, but also lead to compounding effect, to compounded impacts. That often they are the compounded impact is worse than the sum of the single impact. So in this, this is one of the example of the most recent project. I'm working in collaboration with Professor Kees van Westen and other partners, international partners, with two projects, which is the ESA-funded EO for multi-hazards and the Paratus project that we are working on the Caribbean island for looking at multi-hazard modeling and also risk assessment. So we can see here two examples of two multi-hazard events, let's say. So one is the 2021 eruption, which was during in St. Vincent during a pandemic and a dengue outbreak, and that was followed by a hurricane, so a storm, and this has led to several Lars and again compounding effects. But then also in 2024 we had a series of storm and landslides, and these has also lead to several compounding effects, a multi-hazard. So what we are doing there is looking at the assessment of, so modeling what has happened, and then looking at extending to the modeling of other scenario for also including climate change scenario for the future. So this is again in work in progress, but it's a clear example and very recent example on how multi-hazard can have a very strong impact and in volcanic environment. So again, this is it was to show also the different mapping that we did, and especially the work of Salsabilla, the master of Salsabilla, master thesis, and then I wanted to show you also these two applications that could be very interesting for all of us geoscientists, because my colleague Bastiaan van de Bout, he recently developed with a team of colleagues at ITC, he developed these two applications that are made for fast flood modeling and fast slide. So not fast flood, but fast modeling of floods and fast modeling of slides. So we have that in a matter of seconds or even less, using available data and open data. You can have an idea already of the flooding, possible flooding, of possible landslide in across the globe, in all the area of the globe. So I really encourage you. He also recently founded a startup, because it's really innovative and really powerful, I say, tools to really have a very quick assessment of possible flooding in across the globe, because it uses open data and available data, and you can also, of course, you can do improving with more accurate data if you have them, so you can also upload your own data, but also using it like this, and it's very also easy to use, very user friendly, and yeah. So we are working on also using this and applying this in these different multi-hazard contexts to have, again, a modeling of the different hazards. So let's go a bit more into the topic of the article, and also of this the focus of this talk, which is on tsunamigenic flows, because so we have several historic events and very disastrous event, catastrophic event in the past of this type of tsunamigenic flows. So flows, tsunami triggered by landslide or PDC in volcanic environment. And so why this and not the other multi-hazard? So it's because it's actually they present some key challenges. So we have we don't have a comprehensive understanding of this type of flows. We have a data limitation because there are scarce historical records. There is a complex dynamics, so there is this interaction between the mass flows and the water. And there are also modeling difficulties, because there is the difficulties of predicting the turbulence of water displacement, and also the interaction in between the different flows. So that's why this is one of the most challenging topic in volcanic multi-hazard context. We have also monitoring challenge in this field. So we have, because we need specialized techniques in marine environments, which require advanced method. There are coastal barriers, which needs expensive equipment. We have accessibility issue of this coastal environment in volcanic settings, because there is the they need to monitor remote and also dangerous area along the coast. And we have also equipment vulnerability because of the same reason. When we approach the coast where there are these landslide or PDC process, we risk to damage this expensive equipment. So in marine environment monitoring, we have also some sorry. We have also some advancements or innovative technology, but we have also some challenges. So we have to detect submarine events despite the optical limitation. We don't have global coverage as well of the seafloor mapping. We need to monitor the water column, and there is a fast and unpredictable movement also of the sediments on the seafloor, and also we need repeated bathymetric survey. So because of this movement and this constant change of the seafloor, we need also this repeated bathymetric survey. So these are some of the challenges that we face in this type of setting and in this type of process. So why Stromboli? So we went from multi-hazard and why tsunamigenic flows and why Stromboli. And Stromboli, as you all know, is an ideal case study because it has a persistent activities, it has a multi-hazard environment, and it has the potential also. It's not only interesting from a scientific point of view, but it's also necessary for a social point of view because it has the potential of severe events, and we need to protect the communities from these severe events. It has historical tsunamis and which at least 7 events since the early 20th century, and it has extensive monitoring. So we have the possibility to analyze these historical events with data that are available. So this monitoring system includes seismic station, thermal camera, gas sensor, and ground deformation instruments that can give us data about the activity of the volcano, but also it gives us there is also frequent bathymetric survey that gives us also the track of the what we were saying, the changes in the seafloor. Sorry, I have a. So here we can see some activity of the last century of at Stromboli with some of the stars symbolize the tsunami event in recent year. Two of the most let's say interesting one are one that happened in the Middle Ages that is has been recorded by Rosie et al. In 2019, and also the event of the December 2002, where we had the 30 December of 2002, where we had a tsunami triggered by the landslide, which caused severe destruction and damage in the island. And then we have the events that we have studied with the team involved in the NER project in Stromboli. So we studied the 3rd of July 2019 event, where we had an unexpected and large paroxysm that caused extensive damage and 1 fatality, unfortunately. And it also caused a small tsunami wave, so that was registered at in front of the Sciara del Fuoco of 1.5 meter and 0.5 meter close, so 0.2 meter near the village of Ginostra. And even if it was a kind of a small event in that sense, it's really interesting because we have a lot of recording and a lot of data about it, and it has been extensively studied also by some of you. And then we could look at the series of events and trying to back analyze these two. To answer this question, so what was the primary tsunami source? So which process was the main generator of the tsunami? The flow characteristics, so what were the characteristics of the flow that caused the tsunami? The influence of the morphology, and also what are the implications for future events in a hazard assessment perspective. So here is the study carried out by Di Traglia and colleagues that they look at the changes in the morphology across before and after the event of the summer of 2019, and so they could assess the changes in volume on the Sciara del Fuoco. And so we could have an idea of the displacement of the landslide, the subaerial, it was across subaerial and submarine landslide, but also see if there was other events that were happened in that period of time. And we modeled this with the Volk flow, which is a model that has been developed by Kari Galfun at the LMV in France, and which can model the two different flow, so the PDC or the landslide and the water. So it is a two-flow model, and it sees the landslide or the PDC like a flow. So it's based on depth average approximation of Saint-Venant equation, and we can test different rheology and see which rheology is the most appropriate for the flow. So we did some simulation then based on the data that we had on the bathymetry and the topography, and we recorded what was the tsunami wave registered at different points that were similar to the one where we have the field record. So here is a snapshot of the simulation where we can see that there is these two flows, so the flow of the PDC in this case, and then the tsunami wave propagating. And then, so we, after several simulation and back analysis, we found that the best rheology, so the best fitting flow was 1 million cubic meter PDC, and that the best rheology to use was what is called the constant retaining stress, the Dayden-Hopper developed first, where we have a cohesion of 7,000 Pascal for the flow. So based on that, then using those data, so using the best fitting rheology that we could use for PDC, we did then a parametrical study. So the back analysis is useful to kind of narrow down the parameters that are the best one to analyze a certain event, and then use it for future possible scenario. And so we did the parametrical study. We vary the volume and also the duration of the eruption with at the same volume. If we extend, so if we prolong the duration, we have a lower discharge rate. So, and we have that these are the main factor of influence. We also changed the bathymetry because we had a new bathymetry in the course of of the project, and we also saw that the changes in bathymetry was slightly influencing the very slightly influencing the height of the flow, but especially the wave after the second wave. So here it's a bit of a summary of what were the answer of the research question that we saw before. And then for the other assessment, we thought, so this is where I made the link, because I move also in between this project and now I moved to the Netherlands. So this project was funded by the NERC in Plymouth, and then I moved to the Netherlands and I started working with Kees van Westen, and I started working on the two projects that I mentioned before, so the Parato and the ESA project, and with Salsabila we also worked a lot on impact chains. And so I decided for the article also to apply the impact chain on the Stromboli case study to see what were the connection in between what we did in terms of modeling and what we can learn from the modeling to assess our impact chain. So in a way, it's a way for going from hazard to risk. So impact chains are, so because we have in the risk component, we have the vulnerability, the capacity and exposure that are not taken into account in the more physical process that I always studied before. And so if the fact of introducing this tool, which is the impact chain analysis, it allows to visualize the connection between the hazard, the exposure, and the vulnerability. It facilitates the dialogue as well in between different expert communities, but also authorities and responders. We have used, so in the Caribbean we had I was not there, but the Paratus project, they had a workshop with the community and the government representative to really facilitate the dialogue on what is the impact, what are the vulnerabilities of the community in St. Vincent, what we can, in the Caribbean island as well, and what we can do to increase the risk assessment and the resilience. And so it helps also identifying the dependency, and it's often used as a co-creation process, so it's also visual representation to foster communication. So there are these benefits that has the power to clarify. It's quite a simple tool, but it has the power to really clarify complicated multi-hazard relationship, and in multi-hazard context, it's really important because we often get lost in the interrelation in between the different hazards, and reveals hidden vulnerabilities and facilitate the development of a targeted risk reduction intervention. So for Stromboli, what we did was to look at hazard events, but then on a focus on tsunamigenic flows. We look at direct impacts, so on damage to infrastructure, casualty, environmental degradation, or air and water pollution. Then we look at secondary impacts that are the ones that are caused by evacuation, economic losses, health issue, or psychological trauma. And then we look at tertiary and also long-term impact on the economic decline or societal changes on environmental alteration. And so this is the impact chain that we developed, which is very simple, and it's kind of is not a co-creation with the community, so it's more of a, let's say, desk study that we have done. But it already has helped us in seeing what could be the next step in our research and in our collaboration to look at identify and quantify this impact, and to look for possible solution. So, and also this has also again reinforced that for looking into this, we need the multidisciplinary approach where we combine natural, social, engineering and environmental science, and then, as I said, is looking at future direction. So that is looking at community engagement and continue the interdisciplinarity and the collaboration between different disciplines and also institutions to look at effective mitigation strategy. So the last part, I hope I'm still on time. The last part is from risk to resilience. So in this process, so from the death study of what impact chains are, we really look how we really have the visualization of the fact that if without the engaging of the community and without a proper communication, we cannot reach resilience. And so that the interdisciplinarity, I would say, circle, it needs to be expanded if we want to go from interdisciplinarity to transdisciplinarity. So if we want to go to integrate and transcend the traditional boundaries, we need to integrate not only engineer or social science, but we need to include also policymaker, local knowledge, and art. And this last example is a recent that started as a very technical project, but then with the collaboration of artists, it became also an engaging and community-based project as well. So why art in disaster resilience? So the technical data that we provide as geoscientists can be overwhelming or too complex also to understand and analyze. Also for us, when we look at multi-hazard context, it's very important. And art fosters emotional resonance, and so there is a deeper engagement from community and interested parties in general, and it also facilitates the memory. So there is a retention of what has been achieved and of the result achieved, and there is also more motivation for action. So with this last project is not in volcanic setting, but is on multi-hazard setting, and it always starts from the modeling and from the developing new technology for the monitoring as well of hazards, and then involve also art to enhancing community engagement and again communication and collaboration. And so we started from a sensor-based approach and to have advanced modeling and monitoring, and to have engaging visuals to community engagement. So a bit of background. So we leverage on the advances of Internet of Things and wireless sensor network to develop some sensor that were able to detect movement in landslide body and in river catchment. And so we developed this smart sensing network that were tested in the lab, and recently we've published the first article in Geomorphica, still in press, but it will be available soon. And so these are sensors that have their, there is movement sensor, so accelerometer, but there is also a magnetometer, and they detect movements of cobble, or in that case, in the field, we've placed some kind of, I don't know if you see them, you see yes. We place this kind of cube in the field where inside we have this sensor, and then we have a network, and we have a they transmit to the wireless sensor network. They transmit the data continuously, and so we have a track of the movement in the landslide, and also we place it in catchment river, and so you can see here a kind of outline of what we have done in the Sensum project. So we had the laboratory testing, we have both in dry and wet setting, and then we have the field experiment, then we apply the machine learning, and then we did numerical modeling and visualization for community engagement. For the visualization, at the time I was in Plymouth, and they have this immersive vision theater that where it's possible to do this immersive vision visualization. I don't know if you have ever seen some of those. You are maybe there are some observatory that they have something like that. So you are surrounded by this dome, and the video is projected across the globe. At the end, if I have time, I will show you the video. It's not, of course, in the dome version. It's in the 2D version, but it's still quite a nice video, and also again is to show the collaboration, how we can improve the communication with collaborating with artists, because we started so it was me and Alessandro Sgarabotto with the postdoc who was working with me on this project, and we started with the script and storyboard. We started with the collecting picture, doing a stylized animation from sequence of still images, so some trying to learn how to produce a visualization, and then we did the American simulation with so this was also part of the more engineer part of the project. So we did with SPH and physics, which is a SPH model for the flooding. And then we did 360 camera footage, drone footage. But the final video was long, very instructive, but a bit boring, I would say. It was like, it was 12 minutes long, so it was not that long, but still, you can see really the difference in between the two. I won't show you the 12 minutes long because it's really long. But then collaborating with artists, so we collaborated with Musad and Andrew from the University of Plymouth, and then we made the video more compelling, and we were able to generate emotion also with the use of sounds and gaming visualization. And what we did also was a workshop with interest parties, so there were representatives of the government, the natural, the Forest England, and so to engage and to also see what they need for their monitoring of the events in the UK, and what is possible, how is possible to use this technology for hazard monitoring and assessment. So I will show you the video. So you have 2 minutes of video now. I think I'm still on time. If I can, where is it?
Population growth, urbanization and deforestation have made more people vulnerable to natural hazards.
Temperature rise due to climate change has increased the intensity and frequency of storms and other extreme events.
Between 1998 and 2017, landslides affected an estimated 4.8 million people around the globe. In that same period, floods affected more than 2 billion people worldwide, causing extreme losses.
Different technology advances are allowing us to explore new possibilities to mitigate risk and prevent disasters.
These technologies are already improving our quality of life by constantly providing us with useful data and information.
Sensors placed in smartphone locate our position, track our movements, and keep us connected to the web.
So we wondered, can sensors placed in boulders and logs detect movement and transport of debris in rivers and on slopes as they do in our phone for our own activities every day?
To answer this question, we needed first to test them in the lab. We verified if sensors placed in tag inside boulders and logs, in water and below layers of soil, can record the onset of their movements, the mode of movement, and the movement itself.
After this validation and calibration, a network of sensors, placed carefully in boulders, on unstable slopes and in logs and river catchments, is active in different locations in the UK and abroad, detecting continuously their every little movement.
The data we are collecting from them is now helping us in understanding better these natural processes and the type and intensity of motion that may turn them into a hazard.
Making them the backbone of a new, innovative and near real-time early warning and monitoring system for landslides and flooding, helping to reduce the related risk and thus building a more sustainable future for all.
So this is the video, and you can imagine also how it was in a dome. So when you are projected all around you, it's even more impactful. And for concluding, so going back to my childhood dream to be an engineer for the planet, and going across all the project and the collaboration I've done through the years, and also in my work as head of the Center for Disaster Resilience, where I really need to foster and facilitate collaboration in between different departments. And so I came now to the conclusion that we need to be an interdisciplinary team with a transdisciplinary approach for really improving our resilience and to care for our planet. So in this process, you need to cross boundary to go again, outside your comfort zone, as it was for producing also this video, but also collaborating with a lot of different experts from different disciplines. You really need to go outside your comfort zone, and so it means that you make a lot of mistakes as well in this. And this is one of my favorite quotes from Nelson Mandela. That is, "Do not judge me by my success, judge me by how many times I fell down and I got back up again." And this is another quote from my daughter Nora, which is called she called this the marvelous mistakes. So how to learn from our mistakes, so how to learn from our failure to improve and grow and go beyond this boundary. So thank you, everybody. So there was the list of thank you before. I would like to thank you, of course, Daniele Morgavi, Paola Montone, Anita Di Chiara, and the EnergyVu team for having me here and welcoming here all the co-author and collaborators. And thank you for your attention.
Thank you very much, Irene, for this wonderful talk and inspiration talk, I would say. And we are open for questions. First from the audience, and then in the meantime I will also look for the people online just to tell them to remember to click the link and write you down your questions so that I can read for you. Yeah, Jacopo?
Thanks, Irene. Really inspiring talk. I have two questions. So the first one is, if I got it right, then at Stromboli in 2019, causing the tsunami, it was a density current, not a landslide.
Yes.
Okay.
From our simulation, yes.
Okay. And the other thing, I see that I am not updated on the definition of risk. I was left with 3 parameters, but I see that there is a 4th now.
Yes.
So could you explain me? Sorry.
Yes, because then there is a new definition that considers also the capacity. So we don't only have vulnerabilities, but we also in community we also have established capacity to react and act on events, and so we not only consider the weakness, we consider also the strength to assess the risk.
Okay, thanks.
Yeah.
Other question from the audience? I have a small comment for you, which is just my interest in experiment. It's always great, I think, for the next step to probably try to simulate experimentally some of the landslides you've been studying and modeling. Would be.
You mean in the lab?
In the lab, yes.
Yeah, that landslide is always tricky. Flooding or river process, it's in terms of scaling, they're a bit easier to, still challenging, but a bit easier to scale down to the lab's scale. So I've kind of studied landslide in the lab since my PhD, but the scaling is a bit more challenging. So we can only, do a more abstract study of the process and trying to understand, compare what happens in the lab and what happens in the field, to see what are the processes that could happen in both, or what are the ones that could not happen in both. And we recently published with the Simeon Macri, so we did a PhD also on landslide experiments, so debris avalanches experiment in the lab in Plymouth, that is also looking at the scaling issue that we have in comparing process in the lab and process in nature. So it's he did an overview of all these challenges and trying to understand what we can retain really from lab experiment in this field, because of course there is
a very strong influence of the scaling in landslide rather than in fluvial process.
Okay, there's a question.
Ciao Irene, thank you very much for the beautiful talk. I have something which is in between a comment and a question. As earth scientists, we all are very much ingrained, of course, naturally, in the science disciplines we hail from. And it is fairly understandable that it is a bit complex for us to try and morph into something else. This something between a very long list and a complex list in itself. So cross-disciplinarities and stretching our arms towards other forms of presentations, and including art in many respects. Because I know that it is, any of us know that it is not easy and not straightforward at all. Could you tell something about how was what was the trigger, or how did you feel, how did your group feel when prompted into trying to stretch your arms towards reaching out to, say, the art department, for instance? How did you find the links, or the inspiration, maybe?
Yes, thank you for this question. It's really, the core of what I'm doing today. It's a small story again. I actually started to become interested. I mean, I was always interested personally in art, and I'm a singer. I was an actor when I was younger, so I've always been interested in this. But personally, I never thought of combining the two. But then in Plymouth, there is the Sustainable Earth Institute that at the time was directed by Professor Ian Stewart. And I was the research leader of an impact lab project, was on big data. And in that sense, there was a collaboration with the art and architecture department. And one of my colleagues, now I cannot remember the name, but I can tell, she developed mapping tools with the strings and pinpoints, and she tracked, I'm so sorry, I don't remember her name, but she tracked the refugee journey with them. So they provided this group of refugees, they provided these tools, and then they built their own map, and they collected data from this. They could collect data from their journey, but also they connected emotionally with them, and they had a very beautiful project. I'm sorry, I will put it in the comment because I really feel bad that I don't remember the name. And this was really, that was the switch for me, because I always consider also art only for communicate, but that was art and collaboration with artists used for engaging and also collecting data, and have a more in-depth knowledge of the local knowledge and community knowledge. And so this made me think, so it's just art is not only for visualizing things or making nicer or making, more beautiful, but it really can be something that really bring us forward in our work, in our in improving the resilience, and in assessing the risk, and in collecting data, but also in taking action and participatory and having this participatory approach in what we do. So that was my switch. And since then, I always try to put collaboration with artists in everything I do, which is not super easy, but.
Okay, we have a question from the online people following. Juliana Rubia, first of all, congratulates you for the presentation, and she asked, how did you promote diversity and inclusion? I saw it mentioned in the end credits.
This is needs a presentation on its own. But it's another. I mean, I focus on the more, let's say, scientific part, but again, diversity and inclusion is also at the core of what I do in everything I do, and also in how I try to coordinate the center, but also in all our community engagement, or we engage with interest parties. It's my priority list is always to have the more diverse and inclusive environment, and also but then in everyday work is, we can do it in a lot of way. Like, for example, I don't know, in the hiring process, or when we do events, is always having the attention. And it's just not only because I care, or there are a lot of people who cares about it, but it's also, again, it brings something more to the table, and it brings something that make us going forward. And it's a crucial thing to bring it to the table.
Okay, do we have any other questions from the audience? We have none from the online people. I think we can close the seminar. Oh, no, one question.
Hi, and thanks for the talk. It's actually a comment in line with the Umberto suggestion. You mentioned to move out from the comfort zone. Wow, it's difficult. Here, within our colleagues, it's so difficult that we'll work together. Can you imagine to make it, And in some sense, it was really a lesson for us. The group I work with, for example, we are trying to be in a stronger and better connection with archaeologists. We have similar approach, similar site of investigation, for example, tsunami in coastal archaeological sites or stuff like this. But the different language, the different approach, the different way of thinking is incredibly hard to smooth and to merge. Because you should ask something where there is a merging of intention, languages, including arts, I mean. So but you mentioned also a place where in UK there was a specific institution somehow pushing and sustaining this approach. Should we need to have it in all the European countries at least?
I think, for example, art can help in this. It's like connecting the heart. I always see, might be a bit cheeky, but cheesy, but I always see art connecting the heart, not connecting the brain. And if we connect the heart, we can communicate better. So art can help in this. And also, I think the dialogue it's really important, and the listening also. It's when there is a dialogue that is led by curiosity and led by what can I learn from you, instead what can I teach you, or what you need to do to work with me. I think it's the key, and it's like trying to listen and really think that everybody has a piece of the puzzle that I showed at the beginning, a piece of the puzzle to bring, and then only when all the pieces are together we have the artwork that is magnificent as we want it. So, and of course, then there are all the initiatives, and again at the CDR I tried. Actually, it started in Plymouth because there was the Sustainable Earth Institute, but what I created with Ian, we put together a geoenvironmental risk group, research group, and we called people from all the department that could be interested. And then we had frequent meeting where we discussed, for example, the first meeting where what is risk for every discipline. And so they had a presentation and everybody said, for me risk is this, and there was artists, for me risk is this, or architects, risk, health practitioners, engineers, geoscientists. So it was really, everybody said, what is risk for me? And then we tried to find common ground. And again, I think communication and listening and dialogue is really important. So it can start also from a group of people. You don't need an institution to promote this. We did it, by ourselves, and try. And then there are a lot of things that you can do, engaging in like things like this, seminars, but also workshop. I really believe in acts, interactive and sorry. We have a humanitarian engineering master, which is lunch soon. So, so we try to. I try to do a lot of engaging activities, so interactive workshops. To communicate on different level, not only on the speech, like I did today. Yeah.
Okay. Any other questions? No? I think we can close for today. Thank you again for your
Thank you very
wonderful
much.
seminar.
Thank you.